The department has some wonderful innovations going on right now, whether it's carbon fiber in bridges, where we're replacing the steel reinforcement in concrete bridges with carbon fiber that won't rust in the future, or whether it's electronic construction, e-construction or e-project, a pilot that we're doing here in Michigan that isn't being done anywhere else in the country. Many people may hear of the autonomous vehicle, hear of the Google car, but frankly, we're the place to put the world on wheels, and that reinvention, that's happening right here in Michigan. And it will be the place that reinvents the automobile of the future.
Research drives innovation. You're a part of innovation, bringing new ideas to our organization that will help us work smarter and more efficiently. We want to help you make a difference through your role in research. So we've developed a series of web-based training sessions for project managers to learn about their role in research. In this time of smaller government with so many responsibilities, we hope these training sessions, designed for you to take at your own rate, will be helpful. These training modules start with a presentation on our research process, showing you how you can be a part of coordinating the development of innovative research projects. Once you understand our process, you can take a training session on your leadership role as project manager. The next 4 presentations are on some of the important components of research management: meetings, reporting, invoicing, and project deliverables. Feel free to take these modules at your own rate. After you have viewed them, come back and review them as a refresher when you need more information. To reduce the amount of time involved with training, we've condensed a full-day training event into a series of 10-minute web-based training modules, with support resources if more in-depth information is needed. What you're doing is important. You're about to embark on bringing innovation to MDOT, so we would like to leave you with a story or two of others who have done this before you. Kim Lariviere, working with Wayne State University, recently completed a roundabout project I'd like to tell you about. MDOT, like many transportation agencies throughout the country, is turning more frequently to roundabouts as a safer and more efficient alternative to traditional signalized or stop-controlled intersections. Michigan's first roundabout was constructed in 1996. Today, drivers on Michigan's roadways are traveling through more than 100 roundabouts. Research clearly indicates that roundabouts can reduce both the frequency and especially the severity of crashes. However, their relative novelty can leave road users feeling unsure of how to appropriately use a roundabout. And in some cases, unfamiliarity with these types of intersection configurations can result in a temporary increase in crashes immediately following installation. Kim Lariviere was called upon to manage a research project to better understand roundabout driver behavior and effective educational countermeasures to improve safety and efficiency. The results of her project informed the development of educational materials that can be used by MDOT and local transportation agencies. Her project's carefully designed public education plan will help improve a road user's ability to use roundabouts safely and smoothly. Through continued outreach by MDOT and local transportation agencies, Michigan residents will gain a better understanding of roundabouts as a safe and effective alternative to traditional intersections. Kim's project provided the information and the resources to accomplish this important goal. What would you say if you were an inspector and saw this bridge component at a concrete casting plant and it was recently produced for MDOT? My 8-year-old daughter said, "Oh no," when I showed her this photo. What if bridge beams kept cracking like this right after they were produced? MDOT was faced with this problem. Newly cast concrete beams were showing excessive cracking at the ends. Steve Cowell was called upon by MDOT to manage a project with Michigan State University studying the causes of beam end cracking, focusing on the strands of steel like the one shown in this photo called D-bonded strands. After extensive research evaluating all the factors, it became clear that if rigid sheathing was placed around the strands rather than flexible sheathing shown here, there would be enough space for the steel strand to expand, and the beam end would not crack. Steve's project informed bridge designers of the issues with fabrication of pre-stressed beams using debonded strands. Now, Steve is working on implementing the findings of this research to save time and money for MDOT. MDOT trusts you to do your best with research, and we want to supply you with resources to make that possible. Please feel free to contact research managers or go online and review the Research and Implementation Manual if you need more information than provided in these training sessions. We wish you well as you bring innovation to MDOT.